On selection to preliminary design, estimating manufacturing costs. So a brief overview. Manufacturing cost estimation is a preliminary estimation of how much a product in development will cost. There are three main methods of estimating manufacturing costs: analogical, parametric, and engineering buildup. Analogical methods derive the cost of the new product based off of cost of a similar product with subjective modification for known changes in complexity. This is used as a rough estimate, so it does suffer accuracy. The parametric methods use statistical relationships between historical data and known variables to generate a cost estimate backed by defensible data. It's useful when a large set of cost data is available to generate cost estimating relationships, but fails otherwise. Engineering buildup cost estimation uses a bottom-up process where the lowest elements of cost detail, such as labor and material, are calculated and summed up. This method is the most accurate and applicable to find production estimates, and this is the one that we will be using. As for the cost of an engineering prototype, this is determined by the sum of the assembly costs, sum of purchased components, and sum of the manufactured part cost of the prototype. For OTS parts, these are pre-made parts purchased from a supplier. You'll know from your final design how many parts will be needed. When it comes to OTS parts, sometimes you'll have to purchase more parts than you need. And so in order to calculate the correct costs of the parts that you'll be using, you'll take the total cost divided by the total number of parts and multiply that by the number of parts used. Any unused parts are known as the inventory and will not be added to the OTS cost for one unit. Also, make sure to include shipping and handling costs. For raw materials, this is a material that is purchased from a supplier that is modified by your company. You'll know from the final design how much material is needed, and the cost estimation for this can be based on mass or volume depending on the type of material. So mass-based is favored for processes such as casting and molding, where the initial geometry of the raw material does not govern the final product geometry, whereas volume-based is favored for subtractive manufacturing, where the initial raw material geometry has a significant impact on manufacturing time and cost. In order to determine the cost of these purchased materials, they can be calculated either based off of mass or volume, in where the total cost will be divided by either the mass or volume of the material and then multiplied by the mass or volume of the material used. Any unused volume or mass from which you can make another part is inventory and will not be added to the raw material cost. If there's any volume or mass that is unusable, such as chips and end pieces, this should be included in the raw material costs. And make sure to also include shipping and handling. So assembly and the related labor. So we already know how to calculate assembly time, but we need to determine how much that labor costs. So cost of labor can vary depending on the skill of the labor, the location of the manufacturing facility, and the level of benefits received. A generalized hourly labor cost can be calculated as the sum of hourly wage, the cost of benefits, and the cost of the facility. Here we're assuming that your widget is being built in the United States. Below you can see we have the median hour wage data from 2019 for 7 common occupations in manufacturing industries. And here we see that the average cost for US labor turns out being $56.74 per hour to employ one assembly worker, including pay, benefits, and overhead. In order to calculate the energy cost, this is done by summing the customer charge, which is the fixed monthly charge for the meter, billing, and customer service, plus the fuel charge, which is the cost per kilowatt hour for fuel purchased by the utility company to generate electricity, plus the non-fuel charge, which is the cost per kilowatt hour for the utility company to produce and deliver electricity, plus the demand charge, which is the cost per kilowatt for generation and grid facilities needed to meet the peak power consumption over a period of time. So here we have an example where we have a manufacturing facility operating at a monthly 700 kilowatt demand and 200,000 kilowatt hour consumption. The following rates were obtained with the local utility companies. And so we want you to calculate the monthly cost of energy for the facility. So below is the solution for it. So in order to calculate the monthly cost of energy, the customer charge is given, so that no longer needs to be calculated. We know the fuel charge and the non-fuel charge both get calculated based on consumption. And then we know that the demand charge is calculated solely based on peak monthly demand. And so lastly, you sum up the four charges and you get a total of $14,580. So for melting fabrication, which includes casting and molding, most of this cost is going to be due to energy to melt and form the material. It's not so labor intensive, so we can go ahead and ignore the labor cost for these calculations. And so below you can see the equation that is used to calculate the energy to melt and heat to process temperature. It is important to remember that utilities deliver energy in kilowatt hour. So depending on the location, you may have one or more utility options. In the city of Gainesville, for example, GRU offers non-residential electric power at 13 cents per kilowatt hour. And so here we have an example. What is the cost per kilogram to cast aluminum in a process at 1,000 Kelvin? And that'll be around 4 cents per kilogram of aluminum. So for subtractive fabrication, which includes lathe, mill, drill, this is more labor intensive than the melting process. So you do need to calculate cost for energy and labor. Both costs arise from the time required to carry out a fabrication process. Both energy costs and labor costs can be found using the time required to remove a volume of material using basic parameters. Here is a subtractive fabrication example. What are the energy and labor costs to mill away 1 kilogram of aluminum using a 500-watt mill? And so you'll get that your energy is going to be 276.8 kilojoules. Your energy cost, it's going to be about 1 cent. And so your labor cost is going to be $12.30. So consumable tooling costs. So tooling is the consumable items used to make the product, including end mills, cutting inserts, and reusable molds, which have a set life that can be treated as a recurring cost. Tooling and consumable costs calculated on a per part basis use the purchase price of the tool, the lifetime of the tool, and the tool life consumed per part. Note that if the tool or consumable only lasts for one operation, and the cost of the tool in the operation is equal to the purchase price of the tool. Equipment cost is the cost of the machinery and other non-consumable elements that are used to manufacture parts. Equipment includes objects like the milling machines, lathes, sheet metal brakes, abrasive water jet machines, and so forth. It is complex to calculate on a per part basis because a single piece of equipment may be used for many different products over its operational life. For the purpose of the capstone design course here at UF, most of the manufacturing equipment for the course is already available in the MAC building. The equipment in the machine shop is pre-existing, with the cost for its usage being factored into the facility cost or overhead cost component of labor for the part. And lastly, we have additive fabrication, which includes 3D printing. If no in-house 3D printing capability is available, online sources like TreatStock can be used to estimate a cost. If your company has a 3D printer, material is the major cost here. 3D slicers like Cura will estimate the weight of each part, and you can also determine how much filament is needed and order that from a supplier. In order to calculate the cost, you'll take your total cost and divide that by mass of filament. Any unused filament will go towards your inventory and will not be added to the fabrication cost.